And I always say that it's important to study these things because they affect everyone. For instance, the initial example that I gave you in Google Translate where this thing was happening, I actually tried doing that while preparing this presentation, and Google has actually changed that system, and once now you type this, it says she is a doctor, he's a doctor. So they're giving two explanations. And this isn't some touchy-feely PR stunt. This is actually a translation system which works better for everybody.
So we're really excited to bring you Ali tonight for our Science Cafe. So this takes me to our speaker. So Ali is a PhD student at Northeastern, and his research revolves around the novel area of algorithmic auditing. So where he measures how large-scale data-driven algorithms could be exhibiting biased or discriminatory behavior against certain demographic groups. He works to measure as well as find ways to curtail such behavior. So he's going to give you a brief presentation, and then we're going to ask some questions afterwards. So take notes, you know. But also, if you have any questions during the presentation, this is really trying to be a two-way conversation, so feel free to ask as they come up. And without further ado, I'm going to pass it on to our speaker, so take it away.
So, hi everybody, my name's Ali. Thank you for showing up on a Tuesday evening. So yeah, I'm a PhD student at Northeastern. The title of the talk is like Algorithmic Bias. So I'm going to briefly sort of give an intro about what I mean when I say algorithmic bias, what's the sort of work that's happening in the area. And then after the introduction, more specifically, I'm going to talk about this study that we've done for Facebook ads, which is sort of tells you the challenges and the sort of work that's happening in the area. When I say algorithmic bias, what I basically mean is machine learning algorithms and the bias in that. And it's very interesting that machine learning has sort of, not just in the computer science community, but it's sort of become something that's entered the common lexicon of everybody. So everybody knows what machine learning algorithms are. For the unfamiliar, they're basically these algorithms where you don't have to explicitly program things, where, for instance, if you were to program a cat classifier, you wouldn't have to tell the algorithm to scan through the image, identify which pixels have the ears, which pixels have the eyes, and all of that. You would basically just take hundreds and thousands of images of cats, annotate them, and the algorithm would be able to learn these things. So these algorithms are particularly very useful when it comes to, like, for instance, computer vision problems. You use Face ID every day to unlock your phones. It's because the phone has seen so many instances of faces and it knows how to distinguish between them. Google Translate is one of the cases. These algorithms work extremely well for natural language processing cases. Another sort of example of the impact that we're seeing is that the Turing Award for last year, which is sort of the equivalent of the Nobel. We don't have a Nobel Prize, but we do have this thing. That was given to, for instance, Yang LeCun, Jeff Avengers. These folks basically what modern AI looks like today, sort of these neural network algorithms. So the point, the impact has been so widespread. It's all over computer science. Everybody uses these things. So given all of the strength of these algorithms, there's also problems with the machine learning we have right now. This is an example of the Gender Shades project done by folks at the MIT Media Lab. And they found that these commercial algorithms, which are built for gender classification, so they're built by Microsoft, Face++, IBM, anybody can sort of use them. So these algorithms have noticeably poorer performance on darker skinned women throughout the board, and they perform the best for like lighter skinned men. Now that could be because these algorithms were sort of trained on data which had lots of instances of light skinned men, which is why they do better on them. Another example that was doing the rounds on Twitter a while ago was this instance in Google Translate where, so Turkish doesn't have gendered pronouns. There's no he or she, there's just O. So if you type in Turkish, they are a doctor, it will translate to he's a doctor. And if you type like they are a nurse, it would translate to she's a nurse. It's just because the algorithm has seen so many instances of doctors being he, nurses being she, that it just seems like the natural thing to do for it, but shouldn't be happening. Another sort of like to make a point that these algorithms aren't just isolated somewhere in the online space. They actually do have very real consequences for real people. This was a study done by ProPublica. The Compass tool, it's sort of like a, so it's not in line with the machine learning argument I'm taking, but this is a black box algorithm which is used, so it is used to predict recidivism risk of defendants. So when someone comes in for a pre-trial, the judge has to make an assessment themselves, and also they have a score from this. So they use their own better judgment and the score from the algorithm to say whether this person is going to recommit a crime or something. And so ProPublica did this entire study where they took 7,000 risk scores all over Florida, and they saw that the algorithm was systematically worse for black defendants, and it would, even when they had low risk of actually going out and doing something bad, it would just let the white defendants go easily. Now, since I sort of work in the ad sort of space, I'd like to sort of localize the conversation there. And these are sort of, ads algorithms are also important because you interact with them pretty much every day. If you use the internet, you're seeing these ads all the time. One of the first examples in online ad delivery bias was done by LaTanya Sweeney at Harvard across the river. This was a very interesting study where what she did was she took these canonical African-American sounding names and white sounding names, and she did Google searches with those names. And she found out that for the African-American names, there's this website called Instant Checkmate, which is sort of like a background checking website, so you can see people's public criminal records. This website would come back and say, LaTanya Sweeney arrested, and she's a professor, and but when you would search something like Jill Schneider, it would, the same website, the third ad you can see here, will come back and say, located Jill Schneider. So that's very neutral phrasing of the ad. Same website, same ad space, everything's happening the same way. And when you actually see Jill Schneider's profile, she has 4 traffic violations. LaTanya Sweeney didn't. But what's sad about this is, like, this could be potentially harmful. For instance, if you turn in your resume for a job and someone does a Google search on you, it could leave them with very bad connotations about how you are as a person. Now, why this could be happening could either, a explanation could be that the advertiser themselves has set up this sort of discriminatory targeting. And since I work with sort of Facebook, I can tell you that you can possibly do evil things with Facebook ads. Julia Angwin and her team at ProPublica did the study. Before I explain what's on the screen, it's sort of like a primer on about how Facebook ad works. When you're sort of browsing the platform, what's happening is if you're the kind of person who watches like a lot of Tasty or BuzzFeed food videos, Facebook basically knows that you're someone interested in food. And behind the scenes, when an advertiser goes, they can pick interests, food, and you would be sort of in that audience, and someone can run ads to you. So they have all of these attributes. And so what Julie Angwin and her team showed that they could take attributes such as likely to move, buying a house, basically people looking for ads. They would target them, and they would exclude African Americans, Asians, and Hispanics. And this is illegal. You could do that on Facebook, but after this whole thing happened, Facebook has sort of clamped down on it, and you can't exclude races when it comes to. So Facebook, you don't explicitly report your race on Facebook, but depending on the activity that you're doing online, they, depending on the pages you're interacting with, they do make some sort of ethnic affinity inference about you. So Facebook sort of blocked this down. But if you're a really evil advertiser, you can still go ahead and say, okay, Facebook is not going to let me exclude people by their race, but maybe I can exclude people who are interested in black entertainment television, which is going to be a decent enough proxy for your ill intentions. And we also found out that one of the studies I did earlier with some of my colleagues was that Facebook has this very powerful feature called lookalike audiences. Before I explain that, I have to tell you what customers. So there are these features called custom audiences where you can take basically a list of phone numbers, email addresses, or whatever. You can upload them to Facebook and tell Facebook to show an ad to exactly the list of people that you uploaded. So you don't tell them to pick the people for you, you pick the people in your upload. And then you can also ask Facebook, okay, I don't have enough customers at my store. I'm giving you 1,000 people, how about you pick me people similar to that? So sort of like lookalike audiences. And and we found out that if you upload like a very racially segregated list, the lookalike audience they're gonna fetch you is also gonna be very homogeneous in terms of race. So why I'm explaining all of this is just to say that if an advertiser really wants to harm people and be malicious, there's tons of ways to do these things. But that's not what I'm going to talk about today. What we're interested in, that assume that an advertiser is completely not evil. They're just there to run a regular ad just to show it to everybody. What are the decisions that the platforms itself makes, like inside the black box? So an advertiser just set a bunch of parameters, and Facebook has to, of course, make some sort of judgment call on who the ad is relevant to. So that's the part we're interested in. And before I sort of explain what we do, so particularly what we were eventually interested in was looking at these protected category ads, for instance, employment or housing. These are decisions where doing discriminatory advertising is sort of illegal and shouldn't be doing that. But before we get to that, we went through a long process of understanding how Facebook algorithms, this ad targeting system actually works. So I'm going to also walk you through how we do that. So one of the questions we ask is, like, once you make an ad, what parts of the ad are taken by Facebook to say, okay, this ad is relevant to X person or Y person? Also, once Facebook has made sort of a decision on who the ad is relevant to, do they change that decision over time? If some people are clicking more on a certain ad, are they going to steer it towards them, or are they going to stick to their initial judgment? And the third thing is, which is a good sanity check, because whenever you launch an ad on Facebook, it does go through sort of like a review process. So it's likely that someone is sitting behind the thing, moderating, assigning scores. So we also want to check that, are these things actually happening at the hand of humans? Or it was just an algorithm? Because we want to be able to pinpoint and say, okay, the algorithm was making these decisions. And all of this, we're doing this just to understand how this advertising system actually works. Of all the ads that we ran, this is one of them. This is just a link to bodybuilding.com. I don't regularly go to bodybuilding.com, but I'm just pointing to it. So the ad sort of has like some text on top. There's an image. You're pointing to a link. There's a headline. So you can, some of these things Facebook is going to pull out from the website itself. Some of these things you can override and dictate what the ad is going to look like. And so this is just the front part of the thing. Behind the scenes, what's happening is you can specify a daily budget on the ad, and also you can specify the audience that you want to target. And for all of our experiments, what we do is that we make a custom audience of people, and we target all of our ads to this custom audience. So this was important because if we give Facebook a set of people and we tell them to run 2 ads on it, then whatever decisions Facebook makes, it's not because those people are different, it's because they're making those decisions. So whatever ads we run, we give them the same set of people and we let them run ads on them. So as soon as we started doing these things, one of the first things we noticed was that we weren't able to reach women in all of our ads. We were reaching like 60%, 65% men, and we found over time that we were just not paying them enough money. If you pay them, we ran ads for multiple daily budgets, $1 a day, $5, all the way up to $50 a day. And if you're like into numbers, then there's a very strong negative correlation. The higher you pay, the fewer the fraction of men. So you can reach more women. So women seem to be inherently more expensive on the platform somehow. So if you're not a very rich advertiser, you just won't be able to reach women from the get-go. That's how it is. So this was important for us to understand going forward, because we were going to run ads where Facebook at least had the opportunity to win over women in auctions. And now once you understand that, we just stick to $20, because this is $20 is the point where you reach about 50% men, 50% women. So we're like, okay, we're going to stick with this. And now, other than the budget itself, here's 2 ads. Now we want to figure out what part of this ad tips Facebook off towards one side. What makes Facebook think one ad is relevant to men, which one is relevant to women. And we found out that of all the things, the text, the headline, the image is the strongest signal that Facebook takes. So if you run a complete ad with the link is right, the headline is fine, Facebook can arguably go to this link, read the page, understand what the ad is about, but still that reaches around 65% women. But the moment you put in this image, it goes up to 95% women. So the image is a very, very strong signal that Facebook associates with this thing. And it's natural, because images are what users are seeing while scrolling through the thing. So this was also important for us to understand, because if we wanted to tip the system off to measure its behavior, we would just have to like flip the image and we can see all these things. And the second question which I mentioned was, once Facebook has made a decision, does it ever change? So here's an example when we ran the bodybuilding and the cosmetics ads. Bodybuilding ads is around 65-70% men. Bodybuilding cosmetics ad is around 10% women. And this is at the 24th hour. We ran this for a day. But this was the same thing that happened throughout the day. Like once Facebook had made an initial assessment of who this ad is relevant to, they sort of stick to that assessment. And it doesn't really change along that way. Just to like even solidify this point, what we did was, while we were running these ads, we thought it might be interesting to halfway just flip the image. So we have a bodybuilding ad on cosmetics ads. 6 hours later, we just flip the image, and immediately ignoring whatever happened before that, the ads also flip. Facebook does a reclassification, and they're like, okay, this is the new ad. I don't care about historical data. And so we are able to sort of make a very strong claim that it's the image. And we're able to very strongly say that because the click-through rates, like my ads were so bad, no one was clicking on them. So it can't be that people, and the click-through rates are pretty much the same for all groups. So depending, before the flip, after the flip, basically nobody was clicking. It was the image. And then the final thing, is the decision being made by people, or is it being made by machines? So we came up with this trick where we would actually make ads, we would try to make ads which would look like, which humans would not be able to read, but machines would. So how we did that was, if you're familiar with sort of how images are saved, this is going to be slightly technical. If you don't get it, just understand that what I'm trying to do is make ads which would be visible to algorithms, but not people. So this is a 1080 pixel by 1080 pixel image, and like each pixel in the computer is saved as an R and a G, red, green, blue value. So like, and this is like 4 examples, colors from this image. But what happens in PNG images, which is like one of those formats you use, is that you also have an alpha channel, which controls the transparency. So what you can do, if you increase the transparency, then the image starts looking slightly like this, and then if you like go all the way. But the thing is, if you're someone who's familiar with writing computer vision algorithms, the first thing you would want to do is throw away the alpha channel, because that's just useless information. The RGBs are still there. So if a person was sitting behind there, they would just see this. But if an algorithm was there, they would actually see the cosmetics and thing. And we ran these images we thought would be relevant to men on Facebook, and images we thought would be relevant to women. And we do both the visible and the invisible version. And we found out that it doesn't matter if it's visible or invisible, it has the same result. So the male ads are going to reach about 60% men. We also ran like blank neutral ads just to see it wasn't some random effect, nothing there. Also between the women and for the women ads, the invisible has no difference. So it doesn't matter if, it's definitely some algorithm sort of looking at these things, and it's making the decision, because for men and women itself, it doesn't make a lot of difference. So with all of these things, we were able to understand. So now we have an understanding of how this ad system is working. We have a way of measuring these differences across gender. But one really important thing that we wanted to do was to measure racial bias in the delivery system. And unlike gender, Facebook does not report racial statistics. So you can't ask, okay, how many white people saw my ad, which is good. That's exactly how it should be. But we wanted to measure it. So what we did was we started using these designated marketing areas. So these are things used by television marketers to segment geographical regions. Facebook will report breakdowns by DMAs. So you can ask Facebook, okay, how many people in Raleigh saw my ad and clicked on it and all of that. And what we do is we take voter records from North Carolina, where race is public, where the DMA is public, and we build these audiences where certain DMAs contain only black people and certain DMAs contain only white people. So if we, and we upload these to Facebook. So if we know someone in Raleigh or Wilmington saw an ad, we know that's a white person because that's what I gave Facebook to. So we use location as a sort of proxy for race. And just to test this, we ran these ads where there's a country music ad, a hip hop, and a top 30. And we saw these really, really strong results where top 30 was balanced. Country music was 80% white people. Hip hop was like about 90% black people. So we were not expecting the strength of these results, but that's what's happening in North Carolina. I don't know why hip hop and country are so segregated, but that's just in North Carolina we saw that. So we have a way of measuring these racial biases and all of that. So after setting up all of this, I'm going to take you back to the original question that we were interested in, that what about the protected categories? If I run an ad for a job or housing, is Facebook going to make these decisions on that? Because for some cases like this, for marketing reasons, sure, it's the right thing for Facebook to do. But when you come to sort of that legally protected territory, it becomes a little shady. So we started running job ads. And this is a job ad that we ran, find a job in the lumber industry. We put a very suggestive image, so Facebook takes signal from it. We put very descriptive text on it, so we give Facebook everything it needs to sort of skew the ad a certain way, and there's nothing's vague about the ad. And we run a blank image and also like images with different people in it, just to see if that will make any difference. And if you look closely, the black man and the black woman in the image, they're photoshopped because there's no stock photos of those people working in a forest. But when we started running these ads, we immediately started seeing these differences both along gender and along race. And like these ads for the lumber one, on average, they reached about 80% men and like about 75% white users. So Facebook thinks the white men are most interested in these kind of jobs, which is correct in a way, but it's very illustrative to show that this thing is happening, and you can show that. We also ran janitorial job ads, and in this situation, it's the exact opposite, where Facebook thinks only 25% of the audience were men, and only around 25% of them were white. So Facebook thinks black women are interested in janitorial jobs. I'm going to show this ad to them. And this is surprising because the platform is making sort of an assessment on the advertiser's part. We're just giving them the audiences. It's the same set of people. Facebook is doing the sub-selection. And we ran this for like several other things. For instance, working as a supermarket cashier, as a janitor, a nurse. And you see like all sorts of differences in thing, where taxi drivers, Facebook thinks that black people are more interested in that, preschool and all that. And since we also wanted to talk about the housing, like we've run these experiments on jobs, but we also wanted to talk about housing. So we ran, similar to that, we like ran a lot of these housing ads where we would just have an image of a house, with the white family or a black family, would just Photoshop people onto the image. And we found that it's not conclusive, but for the set of ads that we ran, we saw that houses ads which talked about selling houses, like buying houses, were found more relevant to the white users, while the ads for renting were found more relevant to the black users. This was a small set of ads that we ran, but it's still, like, we wanted to make a point that these things are happening in both housing and job ads, which are legally protected categories. So what's the sort of real world consequences of these things? And it's very interesting because at the time we were working on this, the Housing and Urban Development Department started a lawsuit against Facebook where they were like, Facebook is allowing people to do discriminatory targeting. So Facebook is not making enough efforts. People can do sort of discriminatory selection of audiences and show ads to them. And B, they sort of alluded to this point where they said that even if an advertiser is not making decisions, in the back end, Facebook, the sort of decisions Facebook is making is also discriminatory. Like, they're skewing ads a certain ways. And this was just like a myth, like it wasn't clear that it could happen, but we sort of showed that it can sometimes happen, and even if it's not proof, we sort of set up the methodology. So if someone wanted to go and take a stab at the platform and see if these things are happening, then we show that you can actually study these things. And also this has very important implications in reference to section 230, which is sort of this law which allows these online internet companies to distance themselves from the content which is there. So this happened, for instance, in the case of Craigslist, where if someone would put up an ad where they would say, okay, I don't want people like this living in my house. So Craigslist was actually sued for that. And they were like, it's not actually our content, it's user-generated content, and we have nothing to do with it. And that was completely fine. Craigslist got away with that lawsuit completely fine. But what's happening here is that Facebook is making decisions who to show the ad to. So this is completely different. This was the section 230, and how Craigslist avoided that doesn't really apply here. So Facebook is part of the puzzle where they're providing this information, and they're responsible. They're part of the complex picture. Before I sort of, so this is what we found in the Facebook situation. But I wanted to sort of wrap up and talk about why it's important to do studies like this, why we do what we do, because a lot of the questions I get from my friends, well, whatever's Facebook doing, that's just society. And, you know, it's you can't really criticize what's happening there. But I sort of push back on that, and I always say that it's important to study these things because they affect everyone. For instance, the initial example that I gave you in Google Translate where this thing was happening, I actually tried doing that while preparing this presentation, and Google is actually changing that system, and once now you type this, it says she's a doctor, he's a doctor. So they're giving two explanations. And this isn't some touchy-feely PR stunt. This is actually a translation system which works better for everybody. So just because someone went out, measured this thing, and pointed it out, it led to technology being better. And I think that's the whole reason we sort of do these measurement studies. We take these algorithms and we see what's happening in them. And it's important to do that. It's not just society. If something's going wrong, it's sort of our job to fix it. And all of this work is done in collaboration with my awesome collaborators. Piotr is sitting there. He's responsible for a majority of the slides. I've borrowed very heavily from him. Alan's my supervisor at Northeastern. Miranda and Aaron work at Upturn, which is in DC. It's a nonprofit that does public policy stuff and talks about technology. Alexandra is a professor at USC. All of these people are really cool. Their Twitter handles are right there. But yeah, I'm happy to take questions if you have any.
How has Facebook reacted to your study?
So, I mean, they were very thankful. They were like, thank you for sharing this with us. Thank you for, we're doing everything to, because after the HUD lawsuit came out, they were very vocal. They wrote a blog post about it. We're working with people in academia and public policy. We're going to try to fix these issues. But they were thankful, but also sort of critical of the work because they thought that it wasn't really. So we had a chat with them, and they said that some of the stuff you're doing is you should have slightly lighter language in describing what you're doing, because what you're saying race is not actually race. You're just doing approximations of these things, and we agreed to that sort of because we changed a bunch of things in the paper. But we are sort of very looking forward to working with people like in these companies fixing them, but I think we're a little distant from that. So they were just sort of distant from what we were doing. I think if Piotr wants to add anything to that.
So I may have missed this in the beginning, but when you were saying that the demographics of the ad that was being reached, is that from information that excuse me, they're giving you back, or is that how did you get that reporting back?
Yeah, so of course Facebook has this sort of insights panel where they report to advertisers how many people saw this. So we're taking information which Facebook is basically giving us.
And is there a difference between the sent and the responded in that feedback? So can you tell the difference between who it sent it to and who reacted to it in that same demographic breakdown?
I mean, it's not that fine-grained, but you can tell, for instance, how many people saw the ad, how many people clicked on it. So you can see, okay, only 5% of people who actually saw it clicked on it. You can actually distinguish how many of the people who saw this ad had actually seen this before. So how many people are unique, which ones are just repeat views. So yeah, we just take their system. And how I do the sort of thing over time is that instead of just asking them when the ad is finished running, I keep asking them every 2 minutes, okay, how many people now? No. So I sort of have measurements every 2 minutes later where I can say, okay, this is how many people saw it in this time, this is how many people in this time, yeah.
And if I can break the rule of multiple questions, did you do any in-person kind of focus group study to see if there was any human interaction input that might inform this? And if so, do you think that would be helpful in trying to see what's really going on there for the user point?
Actually, yeah, that would be very helpful. If we could see how people are actually clicking on this, or how, because right now the amount of clicks or any that sort of stuff we were getting, it was very little, and we couldn't really distinguish whether these clicks were meaningful or in any way. If we could like sort of install a plugin somewhere and see whether those clicks are happening, or if users are just scrolling past, or that's also very important, because we at some point we were like, okay, even if people are not clicking, are they hovering over this, are they reading this? Like, we would really like to have that information. So if we had that, it'd be much more cooler. I think we might do that at some point. Yeah, but not right now. Yeah.
Who is creating these algorithms that are causing the bias? Are they created by machines, or people creating them? How are they creating them?
It's just people like me, people with computer science degrees. It's just like software engineers back in the company. So I think the thing that happens is when software engineers are given this sort of task to make these things, sometimes they're not trained to think about what things they should be cautious about. So So it's basically just software engineers at Facebook writing these algorithms.
Okay, so they're creating the algorithms that are causing the bias?
They're not doing this, I mean, they're not malicious, so they don't know this is happening. It's just, you give engineers an algorithm to make and you tell them that, okay, just show this to relevant people, and they're going to program that for you. So this algorithm is doing a really good job at figuring out who the ad is relevant to and giving it exactly to that person. The point is, in certain situations, should an algorithm really be making that decision? And I think that's what engineers or product managers don't think about.
So to follow up, this is not a question, it's just a follow up on what you just said. I think we need to involve more, people from liberal arts and so on, because we need more philosophers in tech. We need more psychologists in tech, the good way, That can also go bad, but I'm sure you know what I'm talking about. We try to solve human problems with tech, but then not all human problems can be solved entirely with tech. So let's bring in people from other fields. Thank you.
Yeah, it's a very good point. It's very important.
I too have a sort of follow-up on that. So I was on the other side. I used to work in ad tech back in India before I came here. And so these algorithms, how they usually work is they learn from data. So the first thing is that they are modeled to increase your bottom line, which is profit. And they're not, the algorithms till now are not really worried about racial or gender bias. And the second thing is that the data that is generated is such that the algorithms start modeling these behaviors. And so let's say your data is geared towards black men renting homes versus white men buying homes. It sort of learns that from that data and then starts creating these ad sets, these audience target groups to show, and then directs these ads to these segments of audiences. So it's a combination of not involving these decisions of having considerations of bias, and the representative data is such that it's geared towards bias. It's, I think, a combination of both.
But definitely more sort of liberal arts education needs to be incorporated into this computer science stuff, because one of the initial examples I gave was this gender classification algorithms. Now I feel very uncomfortable, like should you even have an algorithm like that? Like, what is gender anyway? Like, who are you to classify it? Like, if as a computer scientist someone asks you to build that, you should immediately question, okay, I don't think this is right. And we think we need to train computer scientists to do that.
Would you be comfortable talking a little bit more about what drove your interest towards this subject? So
I've been sort of working with Facebook ads for like about a year and a half now. And I was working on the other side of things, where if an advertiser is trying to be malicious, then how could they sort of ruin this? But I've been generally very interested in this sort of algorithmic bias space. I think that's someplace I can comfortably sort of spend my entire PhD working on, and I won't regret it at all. And then my supervisor, Alan, had a talk with some of these folks at Upturn, and one of their interns actually ran job ads for data scientist, nanny, some of the other stuff, and she noticed something where some of these ads were skewing a certain way. So my supervisor sort of had a chat with them, and they were like, okay, something seems wrong here. We need to spend some time working on this. And I was very interested to sort of hop onto that, because I think this is important. So.
Do you see some correlation with how Facebook delivers its ad versus how Google or Yahoo used to deliver this ads? Like, is it pretty similar?
That's something I sort of want to move to in the future, looking at the other platforms. We haven't looked at those right now, partly because Facebook is very, very, we like to call the Facebook system like a walled garden. Like, people are in the system, all inferences are made in this black box. So whatever claim you can actually make a very strong claim about it. Like, Google's system is sort of scattered all over the web. You don't know where they pick the data from. Is it your web history? And also these systems behave slightly differently. But we do suspect that these things would happen elsewhere too. Because the example where I showed the African American names were getting the arrested ad, that was an example from Google and not Facebook. So I do feel that these things are everywhere.
Like you mentioned before, the algorithms are trained on data, and how Ali described, unless there is certain actions put in place to prevent bias from happening, we would expect that all of these algorithms will reveal some form, unless people actually take care to make sure that it doesn't happen.
To what extent is machine learning involved in the algorithms that you are analyzing here?
Basically, the delivery, the algorithms will decide who should see the ad.
Right. Is that the result of machine learning, or is it the result of consciously programming in certain unconscious bias, or unconsciously programming in bias?
I think, like, I would argue that the entire pipeline is full of machine learning, because starting from the point where you're inferring what user is interested in what, that's the first instance of machine learning. And then showing these, and then matching the things that the advertiser is picking. And then, of course, once you put an ad, picking up what's actually in that ad, that's machine learning. So there's like a pipeline of machine learning algorithms. And then finally, the algorithm that decides who the ad should go to, that's also taking historical data into account. So I think it's all over the pipeline.
And it seems like one of the problems with machine learning in a context like this is that it creates a positive feedback loop. Is there a way to deliberately create a negative feedback loop so that this doesn't happen?
You could do that, but then the ad system would be less effective for things it would be effective in, see? So you come to this trade-off thing. I think the right way, I feel like as a very young researcher, I feel like the right way to go about this might be to have categories where optimization should be done differently. And from my experience, I've seen Facebook has actually pretty good policies in some areas. You can't run an ad for patent medicine on Facebook. You can't run a dating app ad unless you have a license. You can't run a political ad. So Facebook has a ton of safeguards for several things. It would be nice to see housing, credit, employment be one of them, instead of messing up the entire system. Yeah.
What do you think should happen, or what do you think is the solution for, let's say, certain groups for which we just don't have enough data compared to other groups? So in other words, minorities versus majorities. What do you think the solution would be for that? Because the ones we have more data for, definitely, we can learn more about them, maybe build ad systems that serve them better and so on. But for people we don't have so much data on, let's say black folks, for example, what happens then? What's the way forward?
I think the only way you can make more inclusive tech is just like have more representation. Like you should go ahead and find more data. For instance, this is sort of the problem of, for instance, in natural language processing, they have these resource poor languages where you don't have enough data about them. So you will never be able to make good enough translation algorithms. Like the only solution is you build data sets in that language so things can work. So I don't think so. Since we're relying so much on data, we can't really say that an algorithm works well for everyone unless we have all sorts of data. And actually, I think the study where the gender shades project, where it showed differences between different races and the facial recognition algorithms, I think IBM or Microsoft, like both of them or either one of them, they actually included more data from these groups and they improved performance. So they were able to do that. Yeah.
Thank you.
And to follow up on this, it's probably also on the tech companies to hire from a more diverse pool. And it took a black researcher to do the gender shade study. And there is probably a bunch of researchers at these companies that have been looking at this data and testing it and running benchmarks and never noticed the problem until a black researcher did her study and showed everybody the problem.
Cool. Well, can we get a round of applause for Ali? Thank you so much for your presentation.